Okay, if we want to divide rational expressions, we want to flip the second rational expression and then multiply. So this actually becomes 3a to the second over 5b to the fourth times 15b to the second over a to the third. Okay, so let's see what we want to do with this. I'm going to rewrite this as 3 times 15 times a to the second times b to the second divided by 5 times a to the third times b to the fourth. Well, 15 I know is 3 times 5, so I can cancel out the 5's. So what I'm left with in the numerator is 3 times 3. And then for the a's, I've got one extra in the denominator. So when I start canceling those out, I'm going to have one left in the denominator. And for the b's, if I have 2 in the numerator and 4 in the denominator, when I start canceling those out, I will have 2 left in the denominator. So this becomes 9 over a b to the second. Okay. All right, on this one, I'm going to do this one out to the side because I may need a little more room. So this is x squared minus 25 over 2x minus 12 times x minus 6 over 2x plus 10. Okay, all binomials, which means I've got to factor each of these before I do anything else. Okay, so if I want to multiply straight across, x squared plus 25, difference of squares. X plus 5 times x minus 5. X minus 6 can't be factored, so I just leave it as x minus 6. Two x minus 12 has a common factor of 2, and I'm left with x minus 6. And 2x plus 10 has a common factor of 2, and I'm left with x plus 5. Okay, so what can I get rid of? I have a common factor of x plus 5. I have a common factor of x minus 6. So in my numerator, all I have left is x minus 5. And in the denominator, I have 2 times 2. Or I can write this as x minus 5 over 4. And that is my simplified answer. Okay, on 18, I have x squared minus 2x minus 24 divided by this. The first thing I want to do here is remember this is a fraction by putting it over 1. So this becomes x squared minus 2x minus 24 over 1 times x minus 7 over x plus 4. Okay, so let's see what we've got here. X squared minus 2x minus 24, I need to factor it. And I'm looking for two numbers whose product is negative 24 and whose sum is negative 2. So that's what, negative 6 and 4? So this factors into x minus 6 times x plus 4. That can't be factored, so it's a prime factor of x minus 7. Of course, 1 is just 1. And this is also a prime factor of x plus 4. Okay, so what do they have in common? Well, I have an x plus 4 and an x plus 4, so I can simplify those. So all I'm left with is x minus 6 times x minus 7 over 1, or I can just write it as x minus 6 times x minus 7. Either one of those would be a perfectly acceptable answer. Okay, number 19. I may have used up too much room down here. We'll see. Okay, so this is, to save a little space, x squared plus 13x plus 56 over 1 times x over x squared minus 36. Okay, so I think that'll give us enough room. All right, so x squared plus 13x plus 56. Well, I'm looking for two numbers who multiply to equal 56 and add to 13. And they are 6 and 7. Oh, no, they're not. Six times 7 is 42. Oh, okay, well, let's change this real quick to 15. Sorry about that. That's what I intended it to be. Okay, so this is going to be x plus well, I really botched this one up. I don't think that's what I intended at all. I think this needs to be 13, but this needs to be 42. Because I wanted it to be x plus 6 times x plus 7. And then, of course, times x. I'm sorry about that. Of course, the 1. And then this is a difference of squares, and it factors into x plus 6 times x minus 6. All right, so that's what I intended it to be. I'll have to fix that for you. All right, so what do I have in common? X plus 6. So I am left with x times x plus 7 divided by x minus 6. Okay, I'll have to go back and remember to fix that one for you. Okay, so hopefully, but before you print this, what this will say is x squared plus 13x plus 42. Okie dokie. All right, so now it says add and, if possible, simplify. Remember, if you add, you have to have common denominators. If the denominators are the same, then you just add the numerators. Okay, so here we have a common denominator, so I can put all of this over x squared y, and that gives me just 2 plus 3. I add the numerators. So my final answer is 5 divided by x squared y. And that's it. Again, I have a common denominator of x minus 7. So now I just add the numerators, x plus 3. Both of those are prime factors. They can't be simplified, so I'm done. Okay, again, on this one I have a common denominator of x plus 1. So I add x minus 5 plus 3x plus 2. Combine my like terms, so I end up with 4x minus 3 divided by x plus 1. This can't be factored and this can't be factored, so there's nothing I can simplify. And I'm done. Okay, on 23, my denominators are not the same, so I'm going to have to find the least common multiple. So x to the third y is equal to x times x times x times y. X squared is equal to x times x. So my least common multiple has to have x, has to have another x, has to have another x, and has to have a y, which is x to the third y. Okay, so I'm going to have to turn each of these into something over x to the third y. There are no missing factors here, so this is already my LCM or LCD. But here, I'm missing a factor of x and a factor of y. So I'm going to have to multiply this xy over xy. So this becomes 5 over x to the third y plus 4xy over x to the third y. Now I just add my numerators. 5 plus 4xy divided by x to the third y, and I am done. These do not have a common denominator. So I'm going to have to find the LCM. Well, x minus 5, that's a prime factor, so it's just x minus 5. X plus 2 is a prime factor, so it is just x plus 2. So my LCM has to have an x minus 5, and it has to have an x plus 2. Okay, so I'm going to have to take 3 over x minus 5 and multiply it by something, plus 2 over x plus 2 and multiply it by something to turn these into a common denominator. Well, x minus 5 is missing a factor of x plus 2. So I'm going to have to multiply by x plus 2 over x plus 2. This term is missing a factor of x minus 5. So I'm going to have to multiply this by x minus 5 divided by x minus 5. Okay, so now I have a common denominator excuse me, of x minus 5 times x plus 2. And my numerator becomes 3 times x plus 2 times x minus 5. Okay, so this becomes 3x plus 6 when I distribute, plus 2x minus 10, all divided by x minus 5 times x plus 2, which gives me 5x minus 4 divided by x minus 5. Oh, I'm so sorry. X minus 5 times x plus 2. Okay. This is a prime factor. It can't be factored at all. So that is my answer. Okay, 25 is exactly the same thing. I have different denominators. So x plus 6 is just a prime factor of x plus 6. X minus 1 is a prime factor of x minus 1. So my least common multiple has to have a factor of x plus 6 and a factor of x minus 1. Okay, so the missing factor here is x minus 1. The missing factor here is x plus 6. So I'm going to take x over x plus 6 and multiply it by x minus 1 over x minus 1. I'm going to take 3 over x minus 1 and multiply it times x plus 6 over x plus 6. Remember, I'm just multiplying by 1 here. So I'm not changing the value, I'm just changing the way that it looks. Okay, so this becomes x times x minus 1 plus 3 times x plus 6 all over the common denominator of x plus 6 times x minus 1. So when I distribute, I get x squared minus x plus 3x plus 18 divided by x plus 6 times x minus 1. So this gives me x squared plus 2x plus 18 divided by x plus 6 times x minus 1. That can't be this can't be factored. So you're done. And the answer on the key is wrong. It says x squared plus 4x. Okay, good place to stop.